So I want to talk about some of the things the tools that I use to help me graph polynomials. So the first thing we better talk about is, what is a polynomial? So all of these functions that you see here, right, these are all different polynomials. So they're different, x to different powers, right? They've got maybe some coefficients in front, numbers sitting in front, right? And they're being added or subtracted, okay? This one here is also a polynomial. It's kind of weird. It's written in factored form, but if I were to go through and sort of FOIL that all out, right, do all my multiplying, I would end up with, let's see, it would be 2x squared plus some other stuff. So I'm just going to write dot, dot, dot. There'd be some other stuff there, right? But you can see that it would end up being a polynomial as well. And one important characteristics that we might talk about polynomials is the degree. So the degree is always the highest power of x, right? So that one's got a 3, a 2, a 1, right? And nothing, right? And so 3 there is the highest power of x. So this is a degree 3 polynomial, right? And this next one here, the highest power of x on there is 2, right? So this would be degree 2, okay? And this other one here, the highest power of x is 5, so it would have a degree of 5. Okay? And actually that degree, whether it's odd or even, is going to tell me something about what the graph of that looks like. So let's kind of just review here about the quadrants. So here's my x-axis and my y-axis. If we divide it up into 4 pieces, right, there's 4 pieces, 1, 2, 3, 4. They often write these in Roman numerals, so I put those there for you too. Okay, so let's start with, okay, well, let's see what happens, right, if I have an even degree. So those would be things if it had a degree of 2, like a parabola, or a degree of 4, or a degree of 6, right? If they're even numbers, okay, and if it has a positive leading coefficient. So let's think about x squared for a second, right? If I had x squared with a positive leading coefficient, that would be an upwards facing parabola. So that would be sort of one option. A quadratic one that had x to the power 4 would look something like this, okay? But you'll notice that all of these sort of have something in common, right? They're sort of pointing upwards on each of the ends, right? So if I were to write those in terms of the quadrants that are written up here, right? Okay, they are sort of starting in quadrant 2, and then they're going to come down, maybe do some loop-de-loops depending on the degree, right? And it's going to shoot back up into degree 1. So I can say here without a doubt, as long as I know that it's even and odd, there might be some weird stuff that happens in the middle, but it's going to start in quadrant 2, right? And it's going to end in quadrant 1, okay? So as long as it's an even degree, so things like degree 2 or 4 or 6, you know what even numbers are. Okay, all right. Whereas if it was a negative leading coefficient, let's go down and talk about that for a second, right? So let's think about degree 2. A parabola with a negative leading coefficient is going to be downwards facing, sad parabola, right? And if it was a quadratic, it's going to do the same thing, but it's maybe going to have some wiggles in there in the middle. Okay. But the end behavior stays the same, right? What happens here at the ends is the same. It's always going to start sort of in this bottom left-hand corner. That's quadrant 3, right? Starts in quadrant 3, and it's going to end in quadrant 4. So as long as we've got even, it's sort of going to have the same end behavior depending on this leading coefficient. Okay. Then let's talk about odd ones a little bit. So let's think, for example, what's sort of the best odd one or the easiest odd one we know? Well, 1, 3, 5, those are all the odd numbers. So let's think about x to the 1, right? So that would be like y is equal to x. Well, that's just a straight line, right? Okay. We were to think about x to the 3 with a positive leaded coefficient. That's the squiggly one, right? That's the to the power of 3, right? Or the power of 5, depending on the function, it's going to have some squiggles in there. But you'll notice it sort of has this same end behavior, right? It always starts in the bottom left and ends in the top right, right? So starts quadrant 3, ends quadrant 1. Okay. And we can think about the same thing here. If it was odd and a negative coefficient, so that think about like y is equal to negative x, right? I'd have a line that goes down like this. Negative x cubed would just be vertically flipped, so they're all going to kind of look like something like this, right? The same sort of behavior. Let me move those a little bit closer to each other. There we go. They all sort of have this same end behavior. They start in the top left, so they're going to start in quadrant 2, and they're going to end here in the bottom right, which is quadrant 4. So end in quadrant 4. So let me just pull this back up so we can kind of see a summary. Right? So what this is telling you is I can actually get a pretty good idea of what the graph is going to look like just by looking at the degree, figuring out if it's even or odd, and then looking at the leading coefficient, right? This number that's in front of the highest power of x. Okay, and that's going to tell me a lot about the shape. Now, I might still have to do some more work, and we'll do some examples to sort of figure out what happens in the middle, right? Does it do some, how many dips does it do? Where exactly does it cross? But the end behavior, what happens at those arrows at the very end, we can already tell a lot, but just by thinking about the degree and by about the leading coefficient.